All right, so this is going to be in three parts. It's going to be about an hour long, so we're a little over. So that's why I want to get going with it. I'm going to kind of run through this presentation, not going to dwell on it, because I want to get into the actual demo portion of the presentation, which is the important part. And then I'm going to be doing the demo on the Docker locally on the second part. And then I'm going to be jumping into the third part, which is the Docker Compose. And doing that with Portainer and Nginx Proxy Manager. Now the local Docker is going to be on my Raspberry Pi, where I'm running it from, and the Docker Compose is going to be on a VPS, virtual private server out of Atlanta, Georgia. All right, so let's get started. So this presentation is this is the 3rd of August, 2024. My name is Dan Calloway. Presentation is Docker and Docker Compose. So let's break it down. All right, so what is Docker? All right, Docker basically is a platform for developers that can use to package their apps into standardized units that are called containers. And so what they do is they bundle the app code along with libraries and dependencies in those containers, and they make the apps portable and self-contained. And you can create images locally or on a VPS, as I mentioned. And you can also automate the build process, and I will actually demonstrate that in this presentation. So you can imagine a shipping container on a cargo vessel. This is basically what the containers are like. They're independent of one another. They're isolated from the underlying system and other containers. They hold all the components necessary to run, and they run consistently regardless of the environment in which they run. Self-containment allows ease of movement between environments. You can do laptop to testing server, production server, and it's worry-free compatibility because of the containerization and the sandboxing. Docker containers are lightweight. They share the underlying operating system kernel with other containers, and therefore they're more efficient than virtual machines because virtual machines require their own operating systems. Kernel version should be greater than 3.1 if you're installing Linux locally. I'm going to be doing this demonstration with Debian 12. I'm going to stay with Debian. I'm not going to concern myself with any other OS. Docker will, or can be installed rather, in Linux and Mac OS and Windows as well. I believe Android also. Always update package index with sudo apt update. That's very critical when you're running Docker containers, especially operating systems like Ubuntu, which I'll be running in this demonstration. And on Debian, you'll need to install Docker, and to do that is very easy. You just use the sudo apt install docker.io command. And then we'll check to see if Docker's running when we start it up. If it's not, you can enable it and then start it and then check the status to verify it. So what's Docker Compose as opposed to Docker? Now, Docker Compose builds on the concept of Docker containerization. It simplifies the apps, however, because it requiring multiple containers. So if apps require multiple containers, then Docker Compose steps in and helps with that process. So you can touch the apps via the web browser, and so let's look at a use case for it. One use case for Docker Compose is complex app with multiple parts, such as a web app with database and cache service. Docker Compose is more applicable there in that case. Typically, you start and manage them separately, but Docker Compose streamlines the process. And that's where Portainer comes in. Portainer is a manager for containers and Docker in Docker Compose. So it defines and runs multiple container apps as a single service. And so how does it work? How it works is you define the apps or containers and their configurations in a single YAML file. If you wonder what YAML stands for, it stands for yet another markup language. So typically Docker Compose is .yml is the file that you would use if you were doing it at the command line. Now, I'm not going to be working with Docker Compose at the command line. I'm going to be working with that in Portainer, which is a little bit different. But Docker, I'm going to be working at the command line. So Docker images to use each service and how they're connected, and environment and variables that are needed is included in that Docker Compose.yml file. So with a single command, you can start, stop, rebuild, or scale the services. You have an isolated environment, so each service is self-contained in its own environment in Portainer, and this ensures that you don't have any conflicts with any other systems that are running Docker Compose. So what are the benefits of Docker Compose? Simplified development is one of the benefits. Developers worry about the code. They don't have to worry about the containers. Consistent deployments, same configuration file, will always allow consistent deployments across multiple environments. Excuse me a moment, let me get some water. Okay, and then scalability is another benefit of Docker Compose. It's easy to scale the individual services or the entire app by adjusting the configuration. Okay, so let's go ahead and dive in the terminal for Docker and see Docker Compose later on and run that in the web browser. All right, so the first thing you would normally want to do when you install Debian is you'd want to run sudo apt update, and you can follow that up with sudo apt dist upgrade. And I'll be doing that a couple of times in this demonstration with the container I'm running in Ubuntu. So let's go ahead and install Docker. So let's run sudo apt install docker.io and get Docker installed on the system. I'm running on a Raspberry Pi with 4 gigs of RAM, so it's going to be a little bit slower than a normal system, but not too bad. Okay. All right, so Docker should be installed, and we can verify that by running which Docker, and it's installed at user bin Docker, so we know it's installed. But let's go ahead and test it. So I'm going to run the first container in Docker now, and it's similar to what you would do with the first program that you would run in any operating system. So we're going to run what's called the hello world container. And so let's run sudo docker run. That's the run command you use. Sudo docker run hello-world. All right, so Docker's going to go out. It's unable to find the image locally in our repository, in our library, but it goes out and pulls it down. It says the pull's complete, and then it presents us with the hello from Docker. So we know that Docker is working. Okay. Now, you've noticed that I've had to use sudo here throughout all the commands I've been running. We don't want to continue to have to do that. And so a way to get away from that, because Docker does require sudo, is to run sudo usermod -a capital G, and then Docker for the Docker group, and then your user ID. Mine is Data Pioneer in this case on the Raspberry Pi. And so sudo usermod -a capital G Docker Data Pioneer. The little a means that it's not the primary group that you're adding Data Pioneer to the Docker, but your Docker is going to be an auxiliary group or ancillary group. Okay. So when you run that, I've already run it, so I'm not going to rerun it. When you run that, you can verify that your user is in the Docker group by running the groups command, and here Data Pioneers in Docker. You will need to log out, log back in for it to take effect, however. All right, so once we've done that, let's go ahead and I'll show you another command. And that command is, now I don't have to use sudo now, is Docker images. All right, And what Docker Images does is it shows us all the images that are currently installed in our library. So we can see here that we have Hello World, which is the latest version of that image. It's tagged as latest, and here's the image ID for it. And it's in our library now, so it's locally installed. All right, downloaded rather. Okay, so let's go out and I'll show you another command. Let's go out and search for the Ubuntu image that I want to run. And so we run the docker search command. And I'm going to just say docker search Ubuntu. And what that does is it presents a list of, I'm sorry, got a question, Pete? Okay, so we got a bunch of Ubuntu images here, you know, like Ubuntu Cortex, Ubuntu Postgres, etc., but I just want to take this basic Ubuntu image right here, which is the Ubuntu Debian-based Linux operating system, and run that one. So let me go ahead and clear the screen, clean up the terminal, and I'm going to use another command rather than just running Ubuntu here initially. I'm going to show you another command that you can pull the image down to the library without actually running it if you want to. And so that command is docker pull Ubuntu. All right, so it's going to go out to Docker Hub. It's going to pull that image down to our local library. All right, so it's doing that now. All right, it's completed. So let's run Docker images again. And so now we see that we have, in addition to the Hello World image, we also have the Ubuntu image. It is the latest tagged version. And then here's the image ID for that image itself. It's 101 megs in size. And it is the complete operating system of Ubuntu without GUI. All right. So now that we have the Ubuntu image in our local repository, it's downloaded, let's go ahead and run it. And so I'm going to issue the command docker run Ubuntu and run the Ubuntu image. Okay, so when I ran it, you notice that nothing happened. It came back to the terminal prompt. All right, so why did that happen? That happened because when I ran Ubuntu with Docker, Ubuntu didn't have anything to do because Docker didn't know what to do with it. Ubuntu does not have, the image rather, does not have anything embedded in it that tells Docker what to do with it. So when I ran it, it just exited. Okay, so it just stopped. All right, so let's see if we can run another image that does have something to do, and I'll demonstrate that for you. So let's run docker run, and then let's run a web server called Nginx. And Nginx, if you're not familiar with it, Nginx is a very good replacement in a sense for Apache. It's a web server. It's also a proxy manager, which I use as well. I've been using it for a long time. All right, so let's go ahead and run that image. It's going to go up now. I'm running it. I'm not pulling it down. So it's going to look for it in the local repository on my system. It's not going to find it, so it's going to automatically pull it down and then run it for me. And that's what it's doing now. Okay, now this image should have something to do, and I'll show you that it does. And so Docker knows what to do with it. All right, so it's doing it. All right, and what it's doing right now is Nginx is sitting there waiting, listening on port 80 for connections, for requests coming in. All right, that's good, but it's not very helpful for us because it's holding up our terminal. It's captured it. We can't do anything with it. And so it's not a very useful application, but I'm going to show you later on how you can make it useful. And for now, let's get out of it. And to do that, I'm going to do Control-C and break out of the container. Let's clear the screen. All right, and so the next command I want to run is a command that shows you containers that are currently running on your system. All right, so let's run the docker ps command. And as you can see, there are no containers running. Why are there no containers running? We ran an Ubuntu container from an image, and we ran Nginx. So why isn't one or the other running? Well, the reason for that is because when we ran Ubuntu didn't have anything in it, so Docker didn't know what to do with it, so Ubuntu exited. The Nginx image that we ran, when we ran it as a container, it did something, but we had to Control-C and break out of it because it wasn't useful for us, because it was capturing our terminal. So nothing is running right now. So there is a command, however. Let me arrow up and bring up an option called an A option for docker ps-a, and that command will present to you on the screen those images or containers rather that were running or are running. So in this case, you've got 3 containers, Nginx, Ubuntu, and Hello World, and all of them have exited. The Hello World exited about 7 minutes ago, and the Nginx about a minute ago here. Okay. All right. So how do you keep Docker containers running to make them useful so we can work with them? So let me show you. Here's the Docker command. I want to run docker run, and we normally would just run Ubuntu and give it an environment to run in, which is the bin bash environment. But what I'm going to do is I'm going to introduce an option here, which is the -it option. And so this is telling Docker to run this image, container from the image, and run it in interactive mode as a TTY in the terminal, and run this image, Ubuntu, which is now locally on our system, and use this environment when you run it. And we're going to use the bin bash environment because that'll allow us to interact with Ubuntu in a bash shell. All right, so I'm going to hit enter, and what that does is it does drop us into a bash shell as root so that we can interact with it. All right, so let's do something. Let's update the system. So I'm going to run well, first of all, I want to show you that we do have an operating system. So you got all the folder structure of Ubuntu. We just don't have a GUI. All right, so let's run apt update and update the system. Get some more water. My throat is dry today, and my eyes are dry as well. I've got dry eye syndrome, so hope I can see the rest of the presentation. All right, so this does take a little bit of time, not too long. It's 4 gigs of RAM, so apologize for that, but it should speed along here. Okay, so it's finished. I'm not going to dist upgrade this, although I should, but I'm not going to save time. Let's clear the screen. And let me go ahead and run my favorite text editor, which is Nano. But wait, Nano's not installed. Okay, so let's go ahead and install it. So this image does not have the Nano text editor installed by default. So let's run apt install Nano and go ahead and install that text editor. All right, so let's clear the screen again, and we can verify that the Nano text editor is installed by running which Nano, and you can see that it's installed at user bin Nano. So now Nano is installed. All right, so let's go ahead and break out of this container. Run Control-D. So hold the Control key down, press the D key. That'll break you out of the container. So let's go ahead and rerun that Ubuntu container that we ran earlier. So let me do the docker run -it Ubuntu bin bash. All right, and so that's this way we're going to be running a different instance of that container, and it does give us a different instance because This one is F7B. This one's F49. So it's a different instance of Ubuntu. And let's go ahead and use that nano editor that I installed and create a file. And so I'm going to create a file called newfile.txt. All right. But what happened? I installed nano and I verified it was there, but it's not there when I can't use it. And the reason for that is it shows one very important thing about Docker containers, and that is they're not stateful. So if the image doesn't have what you want in it that you pull down and you run it and you break out of it, it stops. And when then you go back into another instance of it to use the one you installed, it's no longer there. It's not stateful. It doesn't keep the changes that you install. So we got to find a way to make them keep the changes that you have, or it's not going to be very useful. So let's go ahead and do Control D and break out of this container. And let's run docker ps-a, and you can see that the previous Ubuntu image that was running has exited about 6 seconds ago when I broke out of it. And then the other image that we ran and the container we ran from it exited about a minute ago. So they're in our history. This is basically the docker ps-a gives us a history of the containers that we've been running on our system. So let's run another command that will allow the container to persist. So let me clear the screen. And so let's run that again, docker run -it, and I'm going to introduce another switch, which is the -d option, and run Ubuntu bin bash. And so that's going to be telling Docker to run this as an interactive mode, so we can interact with it as a TTY. And what does the D option do? The D option tells Docker to run this particular Ubuntu image as a container, but run it in the background as a daemon process. All right, so it'll come up. It won't be letting us get into it, but it will be running in the background. So let's go ahead and hit enter. And what we're presented with here is a hash on the screen, and we can't interact with that hash. So, but we can show that particular container is still running by running the docker ps command. And you can see that it is running. Here's the container ID for it, and it's created 17 seconds ago. It's been up for 16 seconds. All right, so it's still running in the background. So how can we work with this? There's another Docker command I want to introduce to you, and that's docker attach. We can attach to that particular container so we can interact with it, because we told it to make it run in interactive mode. And so we need to grab the container ID here and copy it, and then come out, paste that in at the end of this command, and hit enter. And that's going to drop us into a bash shell as root. And as you'll notice, this part of the root after the @ sign is the container ID here. Okay, so it tells you what instance that you're running of that. Okay, so now that we've done that, let's do a couple of things to make this kind of unique, so we can make sure we have this container properly set up. So let's run apt update. And I'm going to do && apt install and reinstall that nano editor. So this is a compound command. Apt update will run first, and then the apt install nano will run second. Again, this is going to take a few seconds to run. It's important. If you don't run this, it will not work, because it won't find nano in the apt cache. Okay, so it's gotten through the update process here almost. And now it's finished. All right, so let's clear the screen. And so how can we keep this container persistent now that we've got nano installed and it's been updated? We don't want to lose the changes we have. The way you can do that at the terminal is hold the control key down, press the P key, and press the Q key while still holding the control key down. So it's Control P Q. And that allows you to escape from the container and keep the container persistent. So the changes that we made should still be there. So let's run docker ps. You can see the container is still running. And that's attached to that container now. So let's run docker attach. And the Docker ID now. I've been copying the container ID rather and putting it at the end, but I'll show you that you don't really need to do that. All you need is the first few characters of that container ID, as long as it's unique to any other container that's running, and it is in this case. So 912 will work here. So I'll just type that in. Okay, so we're actually attached now to that container, and we're running it as root here. So let's verify now that since we did that we still have nano available, and we do. It's still installed at user bin nano, even though we escaped it. But we escaped it with Control PQ, and that allowed it to retain the changes. So let's go ahead and break out of this container with Control D. All right, and let's rerun the Nginx container. All right, so docker run Nginx. So it's going to come up again. Nginx is going to be listening on port 80 for connections. And so again, that's not very helpful for us. And so we're going to have to run Control C to break out of it again. And so I want to show you another way to make this more useful. And I'm going to introduce another command, docker run -it-d, and really not another command, but another option. So I'm going to use the -p option, and I'm going to map port 8080 to port 80 here for this application, since this is a web server. And what the command does here is it tells it to run in interactive mode TTY, run as a daemon process in the background, and then assign port 8080, map it to port 80, so that externally requests coming in from port 80 will be redirected to port 8080 internally in the application, so that Nginx can work with it, a web server. Okay, so let's go ahead and run that. And it ran successfully. We got a stream or hash, which means it was successful. So now that we've got that, how we can interact with it, and what I want to do here is find out what the IP address is of the Nginx web server that's running. And so I can run an IPA command, and that's going to give me the IP address of this Nginx server. All right, so let's come up to the ETH0 information, which is hardwired. And if I come down here, the IP address is 192.168.1.125/24. It's a Class C network, and I knew the IP address in advance anyway because it's my Raspberry Pi, and that is the correct address. So 192.168.1.125 is the correct address. So let's run docker ps. You can see that, of course, the Nginx server is still running. And let's go out to the web browser now, and let's type in that IP address, 192.168.1.125 at port 8080, and hit enter. And we see welcome to Nginx. So if you see this page, Nginx web server is successfully installed and working. So we have a working Nginx web server. Now, that means that any computer on my network right now that can route to 192.168.1.25 on port 8080 will be able to see this web page on any device. So if I wanted to set up a basic web page here with information on it that I wanted my family to see if they wanted to go to this website. They might, favorite place mark or something in their browser, then they could see the information for the day or whatever on the web page, on a web server, on a website. Okay, so makes it useful. That's a useful command. So let's go back or a useful container. So let's go back here and let's run docker ps again. I think I ran it already, but I'll run it again. See, yeah, it's still running. So you can see that Docker is still running. But I want to go ahead and stop this container because I want to do something else here. So let me stop the container. So to do that, there's another command I introduce you to, which is the docker stop command. And B22 is enough information here. It's unique. So if I run B22, that will be enough to stop that container. All right. So let's run docker ps again. And we see that there are no containers running, but I want to run another command, which is docker run -it -d. And I want to introduce another option here, which is different from the other one, which is -- restart. You might think of that as a switch, really, unless stopped Nginx. Okay, so that's telling it to run in interactive mode as a TTY, as a daemon process in the background. And then we're telling it, Docker, that if this container, for some reason, we get out of the container, but we don't explicitly stop it, go ahead and restart it. So that's what that particular option is telling Docker to do. So let's go ahead and run it. Okay, so it's running now. And so if we break out of the container with Control-C, all right, you can run again docker ps, which should normally make the container not be running anymore. We can see that it is running. So we broke out of the container, and Docker said, okay, you broke out of the container, but you didn't explicitly tell me to stop it, so I'm going to restart it for you. And so that's what happened. So it restarted it automatically for us. So that's what the restart unless stopped option does for you here. And you'll see that again when I do the Docker compose. All right, so let's go ahead now and let's rerun. I'll show you how to rerun a container and apply changes and make it persist as well. Okay, so let's do docker run -it ubuntu then bash. Okay. All right, and so let's go ahead and run the apt update for it. And I'm going to show you how to create your own image. This is the purpose of what I'm doing here. Show you how to create your own image from a Docker image that you run as a container. And so I'm updating it now, and then I'll do a dist upgrade to apply any available patches and updates to the packages contained within it. All right, so that's finished. So let's do an apt dist upgrade. And yes. And then when this is completed, I'm going to go ahead and install a new web server in this particular container. And I'm going to go ahead and install the Apache web server. So apt install Apache, and the command is Apache 2, not just Apache. So this installs the Apache web server. And we're going to create an image from this, because we have a web server installed in it now. This is all being done locally, by the way, now from my Raspberry Pi as my server. I'm not using a virtual private server here. Almost done. Okay, it's completed. Let's go ahead and see if Apache is running. So let's run etc init.d Apache 2 status. You can see Apache is not running. So that tells us that in this image that we ran, that we're going to create an image from, the Apache web server does not start automatically by default. It's not running when it comes up. So let's go ahead and start it. So let's do etc init.d Apache 2 start. All right, and let me just, I guess I could have done that, pulled up the command again and check the status on it. Now Apache is running. All right, so let's go ahead and install another package here in this particular image that we're going to create. And so let's run another text editor. So let's apt install vim, the vim text editor. So vimnox is the command that you use there. So let's install that. I don't know how many of you use Vim. I use Nano usually, but I have used Vim in the past. That's okay. It's going to take a few seconds to install this. I want to make sure that we have the Apache web server and another application running so we can verify that we have it. So we got stopped here. Okay, this is a prompt in Debian. We did not install this particular image of Ubuntu using an installer. We installed it as a container, so it's prompting us for locale information. So I'm going to hit 2 for America. And then my time zone is 105, which is New York. And let it go through. All right, so that's normal. All right, so now that we're done with that, I'm going to verify that we have the Vim text editor installed. So I'm going to run Vim, and you can see that Vim, which is the VI improved text editor, is installed. And so I'm going to quit it. Using :Q to get out of it. All right. And so now that we have both of those installed, how can we preserve that? We can use that Control-P, and while holding the Control key down, Q, to get out of the container. So we should preserve the changes that we made. So we should still have the Apache and Vim installed in here. So let's run $ps. Can see now that we have the Ubuntu and the Nginx containers both running. All right. And so how do we create the image that we just set up here in Ubuntu? We can do that using another command called commit. So using the docker commit command, we can take the container ID for the Ubuntu image here, which is 6AF, is enough of it to do. So I'll come over here and type in 6AF and space, and then let's give this image that we're creating a different name. Let's call it Ubuntu / Apache - image, since we have Apache contained in it as the web server, and let's give it : version 1.0. So this tells Docker to commit this image with this container ID with the two things in it, Apache and Vim, from this particular base image, Ubuntu, and we call it Ubuntu Apache-image, a new name, version 1.0. So let's go ahead and run that. And if it's successful, we'll come back with a SHA-256 hash, which indicates completion of the commit. All right, so we got the SHA-256 hash here. And so let's run the Docker images command again. And as you can see, now we have our Ubuntu Apache image. It's tagged as version 1.0, which is the version number we gave it. And here's the image ID for it, and it was created 11 seconds ago. And our image now is 382 megabytes in size, which is larger than the original Ubuntu image because we have Apache and Vim editor installed in it. Okay, so now what I want to do here is, now that we have this image created, we want to stop these containers because I want to do something else, and I want to make sure that there isn't anything using port 8080 here. So let's stop all running containers. And so let's issue a Docker stop. Let's do Docker PS first. Get the container IDs. And let's do a Docker stop. And the first container is the 6AF, which is right here, which is the Ubuntu. And then we'll do the 4B6. So 6AF first. All right, and then let's rerun the command and use the 4B6. All right, so that's all of them are stopped. We can verify that they're stopped by rerunning the Docker PS command. We see we have no running containers here. All right, so what I want to do now is I want to run the Apache web server from our new image, and I want to make sure that none of the containers are running so it doesn't hold port 8080 open. And so let's clear the screen and let's rerun docker run -it-d-p 8080 to port 80 mapping, and let's run our new image Ubuntu /Apache 2 or Apache-image, sorry, and version 1.0. So let's verify that before we run it. Docker run it-d-p 8080 to 80, and the image name we gave it that we created and committed was Ubuntu /Apache-image version 1.0. So let's go ahead and run that. And we got a hash that returned. So let's run Docker PS. You can see that it is running 7 seconds ago. It's been up for 6 seconds. All right, so now if we go out to the web browser again, remember we have Apache installed and we have the Vim editor installed. If we go out here and we refresh the page, we don't see the Nginx server running anymore because we stopped it, but we don't see the Apache web server running either. So why is that? We had it installed, so why didn't it produce the Apache welcome page? Remember when we ran Apache earlier, Apache doesn't start by default. Okay, so when Docker ran this command with our new image that we committed, Docker didn't know what to do with the Apache web server, so it stopped. All right, so let's go back out, and I'm going to show you how we can correct that. And what we didn't do that we should have done is we should have created what's called an entry point for that particular image to tell Docker what to do with Apache. All right, and so let's bring up that previous commit. We've got the container ID here for our image. Let's bring up that previous commit command. It's here in our history. There it is. Let's replace the 6AF image here that we ran earlier in that commit with the 6AE container ID, which has been running from our new image. Okay, so let's run 6AE and then let's back up, and after this commit command I'm going to add a instruction, which is the entry point instruction to tell Docker what to do with Apache. So we're going to do a -- change equals, and then double single quotes, and then we're going to, in upper case letters, entry point, and then open close bracket, and then within the close bracket we're going to do another set of double quotes, and then we're going to type in Apache CTL, come outside the double quotes, put a comma, space, another set of double quotes, and then we're going to enter a dash in uppercase D, foreground. All right, and then we're going to come out here, we're going to put a space, then we're going to come out to the end of this, and we're going to iterate our versioning to version 1.1. We're going to commit a new image, and this new image is going to have the entry point embedded. So let's verify it. Docker commit -- change equals, single quote, entry point uppercase, bracket, single double quote, Apache CTL, in double quote, comma, double quote, dash in capital letters D, foreground, close double quote, in bracket, in single quote, space, the new container ID, space, then Apache, I believe that's one space there, Apache, Ubuntu Apache -image, and we iterated the version to 1.1. So let's go ahead and run that, and that should then commit the new image with the entry point. All right, so we got a SHA-256 hash, which means that it committed properly. If we run Docker images, whoops, got a lowercase, Dan. Okay, images. You can see now that in addition to the Ubuntu image that we committed earlier, we now have the Ubuntu Apache image 1.1. And here's the image ID for it, and it was created 17 seconds ago. Still the same size because we didn't add anything to it. Just created the entry point for it. All right. So now let's do Docker PS. You can see that it is running. Been up for 4 minutes, and it is mapping port 8080 to port 80 TCP for IPv4 and IPv6. All right, so that's working as it should. All right, so let's go ahead and let's stop this container. So let's do a Docker stop, and the container ID is 6AE here. So let's put in 6AE. All right. And now what we're going to do by doing this is we're going to rerun the command. So let's clear the screen. We're going to do a Docker run -it -d-p 8080 port mapping. Can't type today. To port port 80. And we're going to use that new image now that we committed, Ubuntu /Apache -image, and we're going to run 1.1. Okay, so it's Docker run -it -d-p 8080 Ubuntu Apache image 1.1. All right, so we got a hash, so that means it was successful. So let's run Docker PS now, and you can see that it is running. And So let's go back out to the web browser here now that it's running. And let's reload the page, and we can see that we now have the Apache welcome screen. So by putting the entry point command in there, in that instruction, and rerunning the container, the same way we ran it earlier when it didn't present the page, it's now presenting the page. So what's the difference? The difference is the entry point tells Docker what to do with Apache when it runs. All right, so that's an important feature that we need to remember. So let's go ahead and let's stop this running container here. And so let's go back out to the terminal. Let's run docker ps. And so we have the, or I actually already run it. And so now let's run the docker stop command again. And so let's do docker stop. And the image is 647. Stop it. And what I'm going to do now is I'm going to show you how you can automate this entire process so that you don't have to do anything but run a file anywhere Docker runs, and you'll be able to install Ubuntu with Apache that's running, and you can deploy that anywhere you want to, as long as it's deployed anywhere where Docker's running, in any environment where Docker's running. So Docker has something that we can use to do that automation process, and it's called a Docker file, and it's an uppercase name on that file. So it's capital D Docker file, not lowercase d. All right. And so what I'm going to do ahead of that is I want to create a directory to sandbox it. And the directory is going to be called Docker files. All right. I'm going to descend into that directory. That's why it's not finding it, not typing properly. All right, so I'm descending into that directory. And now what I'm going to do is I'm going to use the nano text editor to create the Docker file that we need. So I'm going to type in nano docker capital D, hit enter, and so we can see that we have a file. It's empty, called Docker file, and I'm going to put some stuff in it. All right, I'm going to create the stuff we need to run to automate the process. So the first thing I need to do here is type a from instruction, and it's from the original Ubuntu image that is in our local repository. That's the first one we pull down. All right, I want to now add another line, which is maintainer, who's maintaining this particular automated process image, and that's myself. And I'm going to give my email address here so that I know that. All right, come down another line. I'm going to put in a comment, and this is important, and I'll explain in a moment why. I'm going to skip prompts. Debian operating system has the finicky thing it does, and that it wants to interact with any automated build that you do. So we're going to give it a command here in the Docker file, which is the file we're using for automation, to stop Debian from doing that. And that command is arg for argument, Debian, all uppercase, underscore front end equals non-interactive. And that tells Debian to leave us alone. So arg Debian underscore front end equals non-interactive. So let's comment again, and let's do an update packages. So we're going to update the packages here, and we're going to tell, in this Docker file, tell Docker what to do. And so we're going to issue the run command. So it's going to run, and what are we going to run? We're going to run apt update, followed by semicolon, and then we're going to come out and we're going to do apt dist upgrade. And we're going to give it the Y option to say, don't prompt us for anything, yes to anything you ask us. So run apt update, semicolon, apt dist upgrade -Y. All right, come down. And we're now going to install packages. And we're going to tell the Docker file, tell Debian or Docker what to do. We're going to do run again. And this is what we're going to install. We're going to apt install -y, which is the same for the up above. We're going to tell it to answer our questions. Any questions posed, yes is the answer. And we're going to install two packages. We're going to install the Apache web server, and we're going to install the Vim Knox editor. So we're going to replicate what we did earlier manually. We're going to put it into our Docker file so that it's automated. All right, so those two packages will get installed. And then finally, if you remember, we're going to set the entry point to tell Docker what to do with Apache when it's installed. So we're going to issue an entry point command, entry point, and we're going to tell it Apache to CTL, and then we're going to, in uppercase, -d, a space, and foreground. So you have to have a space there. So let's verify this. It's complete now. So make sure everything looks good. So arg Debian front end equals non-interactive. Run. We're going to run apt update and apt disk upgrade -y. We're going to run apt install -y. Two packages, Apache 2 and Vim Knox. And then we're going to set an entry point with Apache 2 CTL -d foreground. Looks good. So let's go ahead and do a Control X and yes and enter and close and save the file. So we now have the Docker file in the Docker files directory. So how do we build that image for automation? There's another command that we can use, and that's the build command. So we can run docker build. We're going to tag the new image that we're creating with a -t option. We're going to name that new image Ubuntu /Apache-image. We're going to give it a new version, 1.2, and we're going to come out and put a dot, and let me go over what we're doing. So we're building the image from the Docker file, and we're tagging the new image as Ubuntu Apache image. We're iterating it to version 1.2, and the dot there says when you build it, put it in the same directory as you're currently in, which is the Docker files directory. All right, so if this is successful, it should run through the whole process. It shouldn't take very long, and it will not prompt us for anything. And at the end, it will give us a successfully tagged Ubuntu image 1.2. So let's go ahead and hit enter. It starts the build process, and I've got my hand off the keyboard, not interacting with it in any way. Now you can build images this way, make them interactive, and do it as an automated process with, installing as many packages as you want to, and any operating system you want to, or any other package you want to. So it's a great thing, and it allows you to deploy those out in the enterprise. And I'm doing all this from my Raspberry Pi, so not a big deal. It does take a little while to do this. It's going to take about a minute totally to complete. It's at step 5 of 6 right now. If we get prompted for anything, it didn't work, but so far we haven't been prompted. And you want to make sure we don't get prompted, because it's the whole idea behind an automated process. All right, shouldn't take too much longer. It's still in the build process, still getting things, but it'll build fairly quickly. All right, so it's unpacking everything now. Now it's starting to set it up. Now it's setting it up. It's updating stuff, applying SSL certificate to the Apache web server, setting up Apache itself. It's enabling the modules. It's invoking things, setting up policies, and now it's done. So the process is ran through, and now if we get the successfully tagged line, we'll know that it completed successfully. And you have to be patient. That's the one thing I learned. All right, so we got successfully tagged Ubuntu Apache image 1.2. So let's clear the screen, and let's run the Docker images command one more time. And now you can see that we do have an Ubuntu Apache image tagged as version 1.2. There's the image ID for it. And it's created 14 seconds ago. It's a little bit larger than the previous image. All right. So now that we have that successfully completed, let me show you another command that you can use, and that's a command called the remove image command. So the reason for that, you might want to use it, is because we've got a lot of previous images, and you might want to retain those for archival purposes. It's kind of up to you. But let's say you wanted to remove this 1.1 image because you don't really need it anymore. You need the space because it is taking up 382 megabytes. Then there's a command to do that. And so if you run the Docker RMI, which is remove image command, and give it the container, or the image ID for 1.1, which you don't have to use it all, just C5D will work. So come down and put in C5D and hit enter, and it should have deleted that image, but it's telling us that the image is being used by stop container, and there's the container that's stopped. All right, so let's copy that container ID, and we need to go out and look at it. So let's do a docker ps-a, and let's grep for that container ID. And we can see that it does exist, okay? And it's exited 12 minutes ago. All right. So let's remove that container. And it is stopped, so we don't have to stop it. If it was running, so it's being stopped by a running container, we'd need to stop it first, but it's stopped. So let's do a docker rm command, which is to remove containers, and then introduce that container ID, and that removed that container. So let's rerun the docker remove image command that we tried to run previously, and now it's allowed us to delete that image. So now if we rerun docker images again, we can see that the 1.1 image has now been removed from the system. Okay, so let's rerun the command with our new image, docker run -it-d-p 8080 to port 80 ubuntu /apache-image 1.2. Now that we have committed, so it's rerun that. So it reran successfully. Let's run docker ps And we can see that it is running. So if we go back out to the web browser, bring it up again, you can see the Apache web server is running, but let's refresh the page and it's still running. So that means now that we ran that new image from the updated image that we created from an automated process, it automatically started the Apache web server because we put the entry point in the Dockerfile command that was used. All right, so that ends the Docker presentation from the terminal. Any questions about that? It's different. It's kind of like virtual machines, but it's different because it doesn't use its own operating system. It uses the operating system kernel. Just more like virtual machines than it is Flatpak, and because Flatpak is basically a way to install packages. Docker is a way to run them. Understand? Okay. So Flatpak is a containerized. I don't work with Flatpak that much, so okay. All right. So maybe it is similar. I apologize. Okay. Any other questions before I move on to the Docker Compose? And this is going to be short. It's going to be a lot shorter than the other one. Uh-huh. Well, thank you. Thank you. Mm-hmm. Right. They would have to pull that down through the automated process and then go in the terminal in the operating system Ubuntu, and they would have to set up the accounts with the username and password that they want to use as users on that system from that image, and that would not be embedded in the original image 1.2 version. Does that answer your question? Okay. Good. Sure. Absolutely. You could create as many users as you want, recommit the image, automate that, and then you'll have a new image with the new users. Yeah. Yes. It's version 4, Model 4B Plus, I think it is. Yeah, and it's 4 gigs of RAM. Yeah, it's very beefy. I like it. It's not as much as good, rather, if you had 8 gigs of RAM. I mean, if I had 8 gigs or 16 gigs of RAM showing you Docker, it would have gone through, bam, bam, bam. But with 4 gigs of RAM, it's a little slower. But I wanted to be able to run this presentation, so I have to use my desktop and then use something else to do it from. Okay. Any other questions before we move on to Docker Compose? Yeah. Yeah, so what you're saying is you don't want to have your standard user embedded in the image you give out to everybody else. Is that correct? Yeah, the build process I showed you. Yeah, I didn't mean to interrupt you, but you're breaking up on me, so it's hard for me to hear you. But the build process we use to automate the process with the Docker file is the way to do it. Okay. Now there is a way to not have a standard user in Linux be a particular user, but could be any user that you set up. And there's a way to do that. And I didn't demonstrate that here. So that would answer your question about how could you send this out to everybody else and not have it be Data Pioneer, for instance, as the user inside of it. You can do that, but I didn't want to show that. No, the image. the actual image itself. And then if they wanted to recommit an image, change it in some way, they would have to rebuild it and re-automate it. But they could take that image and run it anywhere Docker runs, and it would produce a full Ubuntu operating system without GUI, with the Apache web server and the Vim Knox editor. Yeah, Etsy password. Well, it wouldn't have a standard user initially. So that image would not have a standard user, and I would have to go in that image after I ran the container, and I would have to create that standard user. I would be root administrator initially, because that's how it was created. And so we would create a standard user, Data Pioneer, using the commands. You do that in Linux, and then go from there. And anybody else that had the image would do the same. I just want to make sure that I wouldn't recommit the image with my standard user in it, okay, using the build process automated, and then send that out, because then that would have my standard user Data Pioneer embedded in the image. Make sense? It would be standard home. Wouldn't have a home directory for a user. It would just have the home for root, and that would be it. Yep. But you would have, you wouldn't have even like documents, pictures, downloads. You wouldn't have those. You'd have to create those as well. Now you could do all of that. All right. Set it up exactly as if you were using the operating system every day, daily driver, and then recommit the image and build it again, automated fashion. And then when you send it out to everybody, you would have all of those directories in there. Or you could use the, I forget what the name of it is. There is a file that you can use. I can't remember the name now. But there's a way to set it up so that anybody who installs the operating system would have those folders initially when they opened it up. And there's a name for that, and I can't remember it. I apologize. But in Linux, you can do that. But that's the way I would do it. Okay, so do we have any other questions here before I move on to Docker Compose? I'm going to just show you briefly what I did there. All right, so we don't have any other question. Let me move on to this. I did want to kind of get this done so we'd had some time to talk if we wanted to. All right, so what I'm doing here is I've got some things open already, and for sake of time, and for instance, this is what I do work with every day. I create Docker Compose images and touch applications via the web in a secure manner, and this is the process. I'm going to show you how to do it. And I'll show you why Docker Compose is an advantage over Docker locally. And so one of the applications is Portainer, which is that Docker manager, Docker Compose manager, and here it is. And so if I click on the stacks here, you can see I've got 3 stacks. And 3 stacks, 2 of them are limited because I used them to install Portainer and Nginx Proxy Manager. So I've got one of them called Fresh RSS. All right. And so if I go out here and if I touch that, you can see is the editor button. And you can see within here is a file. Okay. And that file is an image called a Docker Compose image that was obtained from Docker Hub that I copied and pasted into Portainer. And then I went in and I made changes. All right. The PUID, which is the Portainer UID, and the Portainer group ID, I didn't change. But I did change the time zone because it was UTC. So I changed that from UTC to America, New York, which is my time zone. And then I changed the volume location for where Fresh RSS would run. This particular application runs listens on port 80 and runs internally on port 8080. Now this is running, all of this that you see here is running on a virtual private server in Atlanta, Georgia. It's not running locally on my system. and it's running at an IP address totally different from my IP, my WAN IP, or any local IP address. Now, inside here's an entry point. It has it has a command rather for restart unless stopped. All right, so it tells Docker what to do. If this stops, restart it. All right. So if I go out to the Nginx proxy manager that I have running, you can see that fresh RSS has already been installed. And here's the IP address of that VPS server in Atlanta. And it's port 8080 is what it's listening on. And so the initial destination is an unsecure HTTP 4579.220.241 port 8080. I've installed a Let's Encrypt certificate on it, and so it makes it private. It makes it secure rather. And so what I should be able to do is get on the web anywhere in the world and go to this IP address. Now, this IP address is a subdomain of a domain that I own. If I go out here briefly to my domain registrar, and I'll need to log into it. Let me get one moment. And let me log into it. My domain registrar, by the way, is WordPress. And so I own this domain called homelab.routemehome.com. All right. And so coming back here, I've made a subdomain of homelab.routemehome.com called FreshRSS. And if I come back here and I go into the Manage DNS portion, what I've done is I've created an A record called FreshRSS pointing to that IP address. And the time to live on this A record is 3,600 seconds. So it takes about 60 minutes for that to be globally available through the global catalog servers. So anyway, if I come back here to the Nginx Proxy Manager and I click on this, or if I go out on the web and go to that website, it will take me to the application. This is the Fresh RSS news aggregator. I'm not going to log in it and use it. I'm just going to show you that you can touch it, all right? But you can access it this way. So I'm going to go ahead and close it down. And what I did in advance is I'm going to go ahead and show you how I'm going to create a new stack in Portainer for GIMP, which is an application everybody knows about. And I did this in advance because it takes 60 minutes for this to happen. So I'm going to go back into Portainer, or actually I'm going to go out to Linux Server IO, and I'm going to go to the fleet, and I'm going to search for GIMP. There it is, and I'm going to grab it. I'm going to go to the Linux Server GIMP and open up that page, and this is the page for GIMP. I'm going to search to see if there is a Docker Compose image for it. And there is, right here. So I'm going to go ahead and copy that image. This is the image that would be embedded in the Docker Compose.yaml file if you did this locally in your system. I'm not doing that. I'm using Portainer to do it. So I've got a leg up on that. And so what I'm going to do is I'm going to go back out to the stacks. And I'm going to add a stack here. So over here to the Add a Stack button. I'm going to put in GIMP as the name of the application. I'm going to come down, right-click, and paste that image into this interface. All right, so this is GIMP, the services. Here's the image that it's grabbing. Here's the container name that I gave it. We're not going to use any security here on the application itself. The PUIG and PGID are going to remain the same. I'm going to change this information. I'm going to change that to America/New York. It's my time zone. The volume here I'm going to change. I'm going to change that to GIMP // config. All right, the port that GIMP listens on is port 3000, both internally and externally. If you're going to change anything about this image, you don't want to touch this one. You can change the internal port, but don't touch the external. So I could change that if I wanted to 3300 or 9000 or whatever I wanted to. Doesn't matter. I'm not quite sure what this 3001 is here. It might be an administrative port, but I'm not really sure, but not concerned about it. It has the restart unless stopped instruction also embedded in it. So if we do get out of it, it will automatically restart. So if this is set up properly, which I hope it is, I'm going to go ahead and deploy the stack by hitting this deploy the stack button. I should get a successfully completed stack. Okay, so that means it was successful, and here it is. And so if I touch it and hit editor, there it is. All right, now it should be by this time set up. So I'm going to go out to the container. I'm going to hit the container button here, and you can see that GIMP is running. All right, and it's running on port 3000. So I'm going to go back to the Nginx Proxy Manager. I don't want to have to open up port 3000 on my VPS to access GIMP around the world from my container here, Docker Compose container. So what I'm going to do is I'm going to use Nginx Proxy Manager as a go-between, which is great about this product, is Nginx Proxy Manager. You can set this up in such a way that when GIMP, for instance, is looking at port 3000, it's actually looking at port 3000 externally, but Nginx is going to get the request, and Nginx is going to be the first one to receive it, and it's going to say, do I have an application running internally at port 3000? And it's going to look in its list here. It's going to find it, and it's going to say yes, and it's going to direct that traffic to that application, and it's going to do its thing and serve up whatever it needs to serve, which is the GIMP presentation, to the user who requested it. All right, so it doesn't require you to firewall your VPS. Nginx is going to take care of that for you. So how do you do that? Let's go out here and add a proxy host to this button right here. I'll bring this screen down. I'm going to put in a domain name, which is a subdomain of homelab.routemehome.com. I'm going to call it gimp.homelab.routemehome.com. I'm going to click on it, and it puts it in there, loads it, and then I'm going to get the IP address that I need, which I'm going to get that from the domain registrar, which is the IP address here. So I'll copy that and come back to Nginx Proxy Manager and load that in, paste it, and then the port that GIMP is going to be listening on is port 3000. I'm going to cache the assets. I'm going to block common exploits. I'm going to also do WebSocket support, make it publicly accessible, and then I'm going to save it. All right, so it's saved GIMP now as an HTTP internally, port 3000. But that's not what I want. I want to apply an SSL certificate to it to make it accessible worldwide and be secure at the same time. So I'm going to go ahead and click on these three dots over here, hit edit, brings down the screen again. I'm going to click SSL, and under the SSL certificate I'm going to hit none, request a new SSL certificate. I'm going to force SSL so that anybody accesses the HTTPS, it'll force the SSL certificate on it. It'll require it, in other words. I've already got an account set up at my IP address to make all this happen. I'm going to click I agree to your terms of service and click save. And if everything works, it should apply the SSL certificate to it. And it does. All right, so the SSL certificate now has been applied. So if I go out on the web and go to this address, HTTPS, and this address, or click this button, it's going to open up GIMP. And so you've got a working GIMP application you can access from France if you want to. Everybody see that? Okay, so is that good or not? That's a working application. It's, you know, something you can use. It's accessible, it's secure, and it was done through a VPS server in Atlanta using Portainer and Nginx Proxy Manager, and my knowledge of setting up a domain registrar and grabbing the image and setting it up. So it's basically the end of the Docker Compose application portion of this presentation. Anybody have any questions on that? No. You do have to set up an account with Let's Encrypt. You can do it. How did you do it? How did I do it? I installed it through Portainer. All right. That's right. And there it is, Nginx Proxy Manager. It's running right now as a container. You don't have to do it this way. You can do it on the VPS server itself. You can get up there and install Nginx Proxy Manager and run it directly from the server if you want. You don't have to run it within Portainer. And the reason that Portainer sees it as a limited stack is because I did it that way. And so I can't get in and work with it this way. I can, but I haven't figured out how to. Okay? Any other questions about Docker Compose? Okay, so well, that ends my presentation. Let me go back out here and stop the share. All right, so I should be back. Thank you for the time to present today.